Hello guys, welcome to Insta Electronics. So in today's episode, I'm going to show you how you can repair a dead Bluetooth wireless headsets. So in my case, this headset is made by Zebronics. The model is actually Zebronics BE390 sports wireless Bluetooth headset. The price is around $495, and I got this thing as a complimentary gift from Arrow Electronics when I attended one of their conferences in collaboration with Silicon Labs, obviously. So I got this thing as a gift maybe like 2 years ago, and this was my daily driver, like until this obvious damage happened. I was completely satisfied with the audio quality and the sound quality of this thing. But then one day this thing happened, the driver actually came loose, and I just tried, okay, let's fix it, and I tried soldering it back, and then I noticed that there is something wrong with the cable. There is no continuity from the main board to the driver. So at that time I didn't had any time to check it out and to make it work back again. So I just kept it in my drawer for nearly 6 months, and today morning when I tried to make this thing work, nothing is working. So the obvious thing is that when I tried to press the power button right now, nothing is happening. You can see there is no indication or anything happening. Usually when we press this thing, if it was working, you could see a blue and red LED flickering at these two sides, indicating that it's ready to pair. But right now this is not doing that. And also if I try to give some power to it, you can see nothing is happening as well. If it was working, a green, I believe green, I'm not sure, I think no, it's a red color. A red color LED would have lit up, shown that it is taking a charge, but right now it is not doing that one as well. So that clearly indicates there is something wrong either with the battery or with the board. So let's keep all those things to the side and let's see what is wrong with this thing. And if you have one of these kind of devices, like any brand Bluetooth headsets, if it is not turning on, the chances are the main thing will be the battery, because the battery that is used inside these kind of things is the typical lithium ion batteries. But because being so small, it won't hold a lot of charge, and because of that there is a high self discharge rate for those batteries. And because of that high self discharge rate, if you are not topping it up every now and then, the battery voltage will fall below a certain threshold value, then which it triggers the battery protection circuit inside the battery itself, or could be in the main board itself, and telling that, okay, I'm falling below a certain value, don't put me to charge. So that is why when you're trying to charge this thing, it won't take a charge, because the battery has already informed the main board that it is below certain threshold, don't put me into charge. So what we have to do is we have to take a look at the battery status, and then we need to charge the battery in some other ways rather than just directly plugging it through here. So enough of talk, let's just open this thing. And in my case it's really simple. It's just held on by little plastic clips. So with my fingernail itself, let's simply take this thing apart. But be careful, if you break that clips, there is no way you can put it together apart from gluing it together, like with Quick or something like that, super glue or something like that, because those clips are so delicate. So this is the inside of this thing, but there are no user serviceable parts inside this unit. The whole thing is SMD, and not a lot of shops will accept these things for repair, mainly because they don't get the spares very easily. So because of those reasons, most of the shops will simply ignore these kind of things, and below that is our culprit. There is the thing that we want to check. It's made by a company called JYZ High Quality 3.7 volt 1712. I think that is a battery type. You can see bottom side there is nothing. There is the microphone for the call, micro USB port. On the left side there is a battery connection tab, and on this side the speaker connection. That is the only thing that is in here. Everything else is controlled by the CSIR chip. There is a number on the chip. I don't know whether you can read that number or not. I shall put the datasheet of that thing in the screen if it is available. So the first thing, if your Bluetooth headset is not working, the first thing you have to do is check the battery voltage. So for that, conveniently, here you can see they have already provided a couple of pads mentioning 3.7 on ground, or you can check directly at the B plus and B minus points itself. So what I'm going to do is I'm going to take a multimeter, and I'm going to measure what is the battery voltage at that point. So I'll be keeping the multimeter in the frame here. And where is the other wire? Okay, here it is. It's having some issues of itself. So let me just connect it between the ground wire and the positive wire, and you can see, not sure, okay, I'm making a good connection. You can see on the meter it shows 0 volts. Let me make it clear over there. Yep, 0 volts. That clearly indicates the battery has fallen below, has that certain threshold value which I have mentioned earlier, and it looks like maybe the battery is having a battery protection circuit inside that. I think I can see some black thing through that Teflon tape, or it could be somewhere in this chip itself. Maybe there is a chance because the USB is could supply the power to this one and also to the battery through this one. It may have the battery control thing, I don't know. I think it has to be there because otherwise there is no other battery protection circuit which is visible on either side of the board. So to get it done, all you want to do is take a good lithium ion battery. In this case it's a 3.7 18650 battery rated for 2200 milliamp capacity. Does not matter. All you need to make sure is that this battery is fully charged, and what you have to do is just get a pair of wire and you have to connect the positive and the negative of this thing to the positive and negative of the battery here itself. And I don't recommend doing it while the battery is still plugged into the circuit, because if there is something wrong with this motherboard it can damage the entire thing. So I recommend desoldering the battery before doing it, but you know, for the sake of doing it, I'm just going to do it. I'm going to connect the positive to the positive and negative to the negative, and make sure you do the polarity correct, otherwise things will go really bad. So here we are going to charge this battery using this one, because the where is a piece of wire that I need a piece of wire. Okay, I'll use this one itself. So I'll use this wire for the negative and I'll use the positive for the positive, and making sure the polarity is correct, going to touch both the okay, now I'm touching both the connectors. So let me just make sure that I'm not touching the wrong thing. Yep, touching the thing. All right, okay, that must be enough for that. So do this a couple of times, because I'm not sure how long you have to keep it there. It always depends on how deeply discharged your battery is, but right now I kept it there for maybe a few seconds. And let's check the battery once again. Let me bring the meter back to its frame. So you can see it still reads 0. So let me do it once again. You may need to do it a couple of times, as I said, because the battery, it will take some time. And let me remind you one thing, that I'm not putting any resistor or anything in series. That is also not a good thing, because if the battery is completely flat, it's going to take a lot of current. So let me do it once again in the right way. Yep, I'm holding it there for some time, and let's see. Let's measure it once again. Yep, got it, 3.4 volts. It took a charge immediately, because that's why I said that's the reason why I'm not putting any resistor or anything. It just takes the current and gives it a kick charge. So now if I try to turn this thing on, it must turn on. Yep, there it is. As I said, it has recognized the battery, because the battery circuit is now, battery voltage is above the threshold, and it has detected that. And now if we connect a charger, it will detect that charging as well. Now once the battery voltage has reached above the threshold voltage, you don't need to charge the battery like this. You can just plug in your normal micro USB cable and it will charge the battery automatically. Because the battery voltage has now raised above the threshold voltage, it can be charged using the standard micro USB charging itself. Let me plug this thing in, and I may need to turn this thing off. How can I turn this thing off? Yep, see, now it's taking a charge as well. It's getting charged. So that is how simple it is to fix a dead Bluetooth headset. if it is due to the battery, of course. If it is something wrong with the motherboard, then it's pretty much no go, because as I said, the parts sometimes cost more than the whole unit itself. So now all I have to do is I need to find a proper cable, replacement cable for this part to the driver, and I can fix it completely. But for the time being, I'm going to call it as done, because the immediate problem of a dead Bluetooth headset has been solved. So if you're facing similar problem, just try this hack. Just measure the battery voltage. If it is below 3 volts or something, just give it a boost charge using an external battery pack. Don't go through the direct USB, just connect it straight up to the battery and give it a boost charge, and probably that is all it takes to bring it back to life. So I hope it works. Thank you for watching, guys. See you in another video.